Hello everyone. As you can see, we have discussed the first four sums in my last previous video. So we are going to discuss question number 5 to question number 10 in this video right now. Okay. Now here the question is, show that the relation R in the set A 1, 2, 3, 4, 5 given by R as AB such that mod of A minus B is divisible by 2 is an equivalence relation. Here an extra thing is also added. Also show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 4 are related to each other. But no element of 1, 3, 5 is related to any element of 2 and 4. Now this question came in 2015 also and in 2009. So this is an important question, and this will make you understand how we are going to do this sums like these. Now in this question, the solution here is R equals to AB such that mod of A minus B is divisible by 2. Now if we take mod of A minus A, answer is 0, which is divisible by 2. So we can say that AA belongs to R for all A belongs to A. This implies that R is reflexive. Now reflexive we have already proved. We have to prove that R is symmetric as well. Now AB belongs to R, the mod of A belongs to R, which is divisible by 2. Now if we take minus common from here, right, so this will become mod of minus B minus A. This will also be divisible by 2. Now mod, since this is mod, this negative will become positive. The mod of B minus A is divisible by 2. So BA belongs to R. Since AB belongs to R, BA belongs to R. So R is what? It is symmetric. Now let AB belongs to R and BC belongs to R. That shows that mod of A minus B is divisible by 2, mod of B minus C is divisible by 2. Now sum of two even numbers, since these two are divisible by 2, these are even numbers. Even numbers can only be divisible by 2. Now sum of two even numbers is also even. So A minus B plus B minus C will also be divisible by 2. B and B will be cancelled. A minus C is divisible by 2. Implies that mod of A minus C is divisible by 2. So AC belongs to R. Then R is transitive. Since AB belongs to R, BC belongs to R, the AC also belongs to R. So we can say that R is an equivalence relation. Now basically here what we were about to show, that elements of 1, 3, 5, right? 1 minus 3, 3 minus 5, 1 minus 5, they are all giving us the even numbers. So they are divisible by 2. Now the elements of 2 and 4, if we write it 2 and 4, 2 minus 5, 2 minus 4, which is also an even number, which is divisible by 2. But if we take elements of these two sets, 1 minus 2 will give us 1, 1 minus 4 will give us 3, right? 3 minus 2 will give us 1, 3 minus 4 will give us 1, 5 minus 2, 3, 5 minus 4, 1. So they are all giving us odd numbers which are not divisible by 2. So we can say that no element of 1, 3, 5 is related to any element of 2 and 4, right? Now question number 6 here. Let f is a function from R to R defined by fx equals to x raised to the power 4. Show that f is not 1, 1. Now to show that f function is 1, 1, what do we write? We have to show that f x1 raised to the power 4 should be equal to x2 raised to the power 4, right? Now in this case we can write it as x1 raised to the power 4 minus x2 raised to the power 4 equals to 0. So x1 square plus x2 square, and here x1 square minus x2 square equals to 0. This further can be written as x1 square plus x2 square, then x1 square plus x1 plus x2 and x1 minus x2 equals to 0. This we will open with the formula of a square minus b square, a plus b, a minus b. Similarly here, a plus b, a minus b, right? Now in this, the value of x1 will come as x1. If we either one of it will be 0. Okay, now this cannot be 0. there might be some value of x1 plus x2. Now let us assume that this is 0. So x1 plus x2 equals to 0. So this will give us x1 equals to minus of x2. If we assume that this is 0, then x1 is equal to x2. So we are getting two values of x1, that is plus minus of x2. So we can simply there say that f is not 1 function. Now look at this question number 7, where fx is defined as sin x, right? Now you have to show that this function is neither 1 nor onto. Now for 1 function, can you see that for one value of x, let us say for any value here, on the graph we'll have one value here, here and here. We'll get three values simultaneously. Okay, for three values of x, we'll have only one value of y, right? So this is the case of many to one function. This is not 1. Okay, so we can write distinct elements in R has more than one pre-image in R. Pre-image means the values of x, right? Now so we can say f is not 1. Now range, we are talking about the range. The range lies between -1 to 1. Now since this function is from real number to real number, the codomain is the set from where we find our range. So codomain is the set of real numbers, and for any value of sin x, we'll get our range will be from -1 to 1, right? For any value of sin, because the graph of sin lies between -1 and 1. So for any value of x, sin x the range of sin x will be from -1 to 1. So the range lies from -1 to 1. So we can see that codomain is not equal to range. Codomain is what? Set of real numbers, and range is the part of this codomain, right? So they are not equal. So codomain is not equal to range. So we can say, so f is not onto. Now we are going to start with composite functions, where fx equals to x plus 7, gx equals to x minus 7, and we have to find fog of 7. Now since inside the bracket here it is x, so in the function wherever it is defined, in place of x, we will change whatever value we are going to write here, right? So f of g7, we can write fog of 7 as f of g7, right? This can further be written as f of g. In place of x, we have 7, right? So if we are going to put here, so this will be in place of x, 7 minus 7, right? So this is going to give you f of 0, right? Now fx is equal to x plus 7. So f of 0 will be in place of x, we have to put 0. So in the function where it is defined, that this will be 0 plus 7 equals to 7. This is your answer. Now the next sum is fx equals to x square minus 3x plus 2. F of fx you have to find, right? Now in this case, f of fx is what? X square minus 3x plus 2, right? So in place of x, you have to write this. It means that x, in place of this x, you have to write this entire thing, x square minus 3x plus 2, and this is x square, right? Minus 3. Now again in place of x, You have to write this entire thing within the bracket, which is x square minus 3x plus 2, and then finally this one plus 2. Right. Now if we are going to open up this bracket, so we are going to apply the formula of a square, a minus b plus c whole square. This is going to give us a square plus b square plus c square minus 2ab plus 2ac minus 2bc. I hope you know the formula of a plus b plus c whole square. Because of this negative sign, wherever we have the odd terms of b, that term will be negative, right? Now open this up. This will be x raised to the power 4 plus 9x square plus 4, then minus 2ab, 2 3s are 6, x cube, so minus 6x cube, and then 2ac will be 2 into x square into 2, 2x square into 2 will be 4x square, then minus 2 3s are 6, 6 2s are 12, 12x, right? Now open up this, minus 3x square plus 9x minus 6 plus 2. Now add the like terms. X raised to the power 4, we have only one term, x cube minus 6x cube. Now x square, 9x square plus 4x square gives you 13x square minus 3x. So plus 13x square minus 3x gives you plus 10x square, right? Plus 4 plus 2 plus 6 minus 6, that gives you 0, right? So your answer here is x raised to the power 4 minus, okay, x term is also left. Now here x ka term is minus 12x plus 9x, so minus 3x. So this will be your answer for this. Now this one is very good question, where fx is equal to 3 minus x cube raised to the power 1 by 3, that is cube root, right? And you have to find f o fx. Now this can be written as f of fx. So f of 3 minus x cube, right? Now in place of x, this has to be kept, right? So 3 will be written as it is, and in place of x you have to write 3 minus x cube raised to the power 1 by 3, and this entire thing whole cube. And then this, if we are taking this bracket, so and this entire thing will be 1 by 3, yani ki cube root of this entire function 3 minus x cube. So this is 3 minus x, this is x, and this is cube. 3 minus x cube ka cube root. Understood all of you? Now here 1 upon 3 into 3, this gets cancelled. What we are left with? 3 minus x cube raised to the power 1 by 3. Okay, now when you are going to open the bracket, this will be 3 minus 3 plus x cube raised to the power 1 by 3. This gets cancelled. What we are left with? X cube, cube root of x cube, or x raised to the power 3 into 1 by 3, which is equal to x only. This will be your answer. Now question number 11 to 15 we will discuss in our next video. So please subscribe my channel so that you can get the notification of the video whenever I will upload it. Thank you.